All right, 3.2, using tape diagrams. All right, so you can use tape diagrams to represent ratios and solve ratio problems. And so example 1 is called interpreting a tape diagram. Hopefully, I'd like you to turn to page 116 in your book to kind of follow along, because some of these are word problems, so it's easier to do than oftentimes having me writing all this or whatever. I will take a picture of it, but just to kind of give you an idea. So you should be open to page 116 in big green. All right, this can get a little confusing, so please make sure you follow along here. All right, so the tape diagram, which is this right here, so this is what we consider a tape diagram. It represents the ratio of blue monsters to green monsters you caught in a game. So you caught 10 green monsters. How many blue monsters did you catch? So if they're telling us that we caught 10 green monsters, that means this is representing 10 because there's only one of those pieces of the tape, okay? And if you look over here, it says the tape diagram shows that the ratio of blue monsters to green monsters is 3 to 1. That's where we get 1, 2, 3 to 1. But once you go back up and read it, it says you caught 10 green monsters. That means nothing if it's 3 to 1. Remember, the 3 to 1 doesn't necessarily mean that we have 3 actual, tangible things or monsters in this case. It just means it's one piece of it, right? Or 3 pieces of it, or 3 to 1. So the reading tells us that you caught 10 green monsters. How many blue monsters did you catch? So your job is to take, if green equals 10, that means each of them, because look at, they're all matched up, right? This one equals 10, this one equals 10, and then this one equals 10. So how many blue monsters did you catch? They're not asking us for a ratio. They're asking us to interpret, using the tape diagram, what the ratio means. The ratio means that we ended up catching 3 times 10, because there's 1, 2, 3, right? Which equals 30. And it says how many blue monsters? 30 blue monsters. So now that I understand that those are not necessarily equal, you have to be really careful of the wording. Try this one real quick. The tape diagram represents the ratio of gifts received to gifts given. You received 4 gifts. How many gifts did you give? Take a minute, pause it, and try it out and see what you come up with, and then I'll have the answer ready for you. All right, hopefully you gave it a try. Basically, if you received 4 gifts, how many gifts did you give? That means that this is equal to 4, and so is this, and so is this, and so is this. And we know that 4 times 4 equals 16. So how many gifts did you give? We gave 16 gifts, would be our answer. Example 2 is drawing a tape diagram. So they're going to give you a word problem, and then you'll have to create the tape diagram to help represent what's happening. So you start off with the problem. It says there are 3 bones in a cat for every 4 bones in a dog. The cat has 240 bones. How many bones does the dog have? So again, we start off with our tape diagram. So you're going to set it up like this. I got my dog and I've got my cat. And then my tape diagram, I'm going to go up to what they have. I'm going to read out what the ratio is. There are 3 bones, so for every cat, and there are 4 bones for every dog, in a dog, okay? So if I know I have 3 and 4, I want to set up my tape diagram to represent 3. So I'm going to go 1, 2, 3, okay? And then for my dog, I've got 4. So I'm going to set it up to represent 4. Try to keep them as equal as possible. So what this is showing me is that there are 3 bones in a cat for every 4 bones in a dog. So these 3 parts right here represent 240 bones. We don't know what these 4 parts represent right now. That's what we're trying to figure out. So what you need to do is take the 240 bones, okay, and I'm going to divide it by 3. The reason I'm dividing it by 3 is because I have 3 parts here. Those parts are the tape diagram that help us understand what we divide them by. So now if I divide 240 divided by 3, and you would do some side math, you would end up with 80. 80 bones is what each of those represent, okay? So that means this is 80, this is 80, and this is 80. We know that these two are equal because it's a ratio. Remember, it's different quantities of things, but it's the same in the tape diagram. Okay, so now all of these equal 80. If all of those equal 80, now I need to take my 80 and multiply it by how many parts we have for the dog, which if our ratio is 3 to 4, we have 4 parts, and 80 times 4 is 320. So my answer is, this question mark is 320 bones. And that's my final answer. All right, I want you to do this try it. I want you to look back at what we just did in your notes, and I want you to try to do the try it with it. It's the same idea. Set up what is your comparison, what is your ratio, and then set it up and give it a try. You'll see the answer next, so make sure you follow the steps. All right, just as a check-in, hopefully you have your tape diagram set up like this. All right, and what we know is that the small snake has 150 bones. That's total. So we have to take 150 and we have to divide it by 1, 2, 3, and we get 50. That means that each of these tape diagrams equals 50. So now figure out how many bones the large snake has. You should have come up with each piece of the tape diagram equals 50. 50 times 8, because there's 8 things here, right? 50 times 8 is 400. So how many bones does a large snake have? It has 400 bones because the ratio tells us it's an 8 to 3 ratio. Example 3 is using a tape diagram to solve a ratio problem. The problem is as follows. The ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. The monthly allowances total $40. So how much is each allowance? So you need to create a tape diagram representing the ratio of 5 to 3. In order to do that, you think about what the 5 to 3 ratio means. First of all, you have you, and you have your friend. Okay, so between the two of you, we know that each of them represent a piece, but you represent 5. So I'm going to make a tape diagram that shows 5 pieces, okay? Should look like that. Your friend is going to show the ratio of 3. So I'm just going to draw enough to make sure it's equal, and it shows 3, okay? What we do know that there are 8 total parts represented here, okay? The 8 parts represent a total of $40. Okay, so it should look like this. 8 parts representing $40. That means what we have to do is know that if we've got $40 total, how many parts do we have total? 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. That gives us an amount of $5. Put that over there. That means each of these is worth, okay? It's kind of what we just did with the other example. Now I just can simply add them up. So 5, 10, 15, 20, 25. That means I have $25. 5, 10, 15. My friend has $15. So how much is each allowance? The answer to this question is so your allowance is $25 and your friend's allowance is $15. What you basically just did was you took a ratio, you had a total, and you divided it up. Now, some kids like to just do the division and move on, but at least if you have an idea of how a ratio table works, that would be helpful. All right, last thing for this video. If you could use a tape diagram from the example 3 that we just did, and now try and do the what if, okay? Repeat the example 3 when the ratio of your monthly allowance to your friend's monthly allowance is 2 to 1 instead of 5 to 3, okay? I'll have the answer for you after you pause it. All right, this should be your answer. Kind of see how I did the parts here. I broke it up. I have 5 total parts. I know they still equal 40 because that's what it says up here. I took the 40 that it equals total and I divided it by 5 because of the 1, 2, 3, 4, 5. Got 8. That means each of these pieces now equals 8. Now I took 8 times 2 because that's what my ratio showed. It gives me $16 for me. 8 times 3 is how many it showed for my friend. 8 times 3 is 24. And that is it.